Hello all, I am your friend Sasidharan, invented easier rule of divisibility than our early contribution, which is helpful for every one of us for easy calculations. First, let us define the general divisibility rule as the shortened way of determining whether the given dividend is divisible by the given divisor. Let's see the early contribution, what we usually use in our day-to-day calculation as follows. Now, we'll go into my contribution, which has so many advantages over the LA contribution, which has the following limitations where we use different rule for different divisor, and the second one is can't find a remainder so easy. So, by overcoming those 2 points as a drawbacks of a LA contribution, now we go into my contribution where we can find a fixed method for a different divisor and can get out a remainder very easily. Now, we will see the general syntax for my invention. For example, let us take the dividend as a 3-digit number as A, B, C and common divisor as Y. Now, leave the last 2 digits, that is B, C, and multiply the remaining digits with the magical number X. The multiplied answer termed as D. Then add D with the last 2 digits B, C and then check whether the resultant number is divisible by Y. Then it is confirmed that ABC will be divisible by Y. Now we have to find what is that magical number X, which has a mathematical expression as X is equal to 100 minus Z, where it just signifies the number divisible by the common divisor Y, which is less than and nearest to 100. So for example, we take a divisor 7. The number less than and nearest to 100, which is divisible by 7, is 98. Then the value of X is 2 and the value of Z is 98. Similarly, when you take a divisor 8, the number less than and nearest to 100, which is divisible by 8, is 96. Then the value of X is 4, where the value of Z is 96. Same way, we can take for 11, the number less than and nearest to 100 is 99, where X gives the value of 1 with Z tends to 99. And for the divisor 13, the number less than or nearest to 100 is 91, which is divisible by 13, signifies that the value of X is 9 with the value of Z is 91. With those above example, we have the inference that the value of the magical number X can be found for any divisor. Now, let us go into my conceptual process. First, we take an example of a 3-digit number 364 as a dividend. Whether this 364 is divisible by the divisor 7. Now the process is that we have to check whether the number 364 is divisible by 7. As per my general syntax, first take out the last 2 digits 64 as a separate digits and multiply the remaining digit 3 with our magical number X. For the divisor 7, the magical number X is 2. So multiply 3 with 2, the answer is 6. Now add this 6 with the remaining 2 digits 64, which is equal to 70. As a resultant, 70 is divisible by 7, then it is proven that 364 is divisible by 7. So we can check this in our normal division also. The answer is same. With the help of my invention, I have proven that it is easier for us to find whether the 3-digit number is divided by the common divisor. Now we check with the 4-digit number. The example what we have taken for the 4-digit number is 5523 as a dividend, and to check whether this 5523 is divided by the same divisor 7. As per my syntax, now leave the last 2 digits 213 and multiply the initial 2 digits 55 with the magical number x, which is 2. Now multiply 55 with 2, we get the answer of 110. Now add 110 with the remaining 2 digits 23. Now the resultant is 133. And this is also can be simplified with the same syntax. Leave the last 2 digits, which is 33, and multiply 1 with the magical number 2, and we get 2 as a resultant. Add this 2 with the remaining 2 digits 33. The resultant is 35, which is a divisible of 7. Now it is proven that 5523 is also divisible by 7. Yeah. In normal division also, it is applicable that 5523 is divisible by 7. Hurray, yeah, the result is proven. Okay, till now we have seen the one side of the rule of divisibility, that the number is divisible by 7. Now we can see that the other side of divisibility rule, the given number is not divisible by 7. For example, let us take 98943 as a dividend, and we have to check whether this 98943 is divisible by the divisor 7. Applying the same rule, where leaving the last 2 digits 43 and multiplying 989 with the magical number 2, the answer we get is 1978, and add this 1978 with the last 2 digits 43. As a resultant is 2021, which is little bigger for our calculation. Again apply a rule. Now the answer after applying our rule is 61. Unfortunately, the number 61 is not divisible by the number 7. And so this number 98943 is also not divisible by 7. And in our normal division also, it has been proven that 98943 is not divisible by 7. Now you can ask me what's special in my invention, isn't right? Here comes the answer for you, that my invention is an upgraded version over the earlier contribution, where we can find the remainder, the number, without performing the normal division. We know that when the number is divisible by the divisor, then the remainder is 0. In case if the dividend is not divisible by the divisor, then what's the remainder? Come on, let's see into it. Let's see the example to find the remainder. Now we want to check whether the number 458 is divisible by 7. If not, what is the remainder? First, apply the rule. Leave the last 2 digits 58 and multiply 4 with the magical number 2. Then we get the answer 8, and add 8 with 58. The resultant number is 66, which is not divisible by 7. Yes, of course. Next, how to find the remainder? The resultant number is 66. Now we have to find the number divisible by 7, which is less than and nearest to 66, which is 63. Thus the difference between 66 and 63 is 3. Thus 3 is the remainder. Now we can check the remainder in our normal division also. Hurry, yeah, it works. That replies the same answer in both the methods. We can check with another example. Let us take a 4-digit number 6934, whether it is divisible by the divisor 7. Leave the last 2 digits 34 and multiply 69 with the magical number 2, and we get an answer of 138. Adding 138 with 34, we get 172. Again simplify by applying the rules, we get a final answer of 74. Now it's time to find the remainder. The number which is divisible by 7, which is less than and nearest to 74, is 70. Thus the difference between 74 and 70 is 4, which is a remainder for the dividend 6934 when we divide by the common divisor 7. Now we can check the remainder in our normal division also. Hurry, yeah, it works. That replies the same answer in both the methods.